Okay, we're working on graphing rational functions. I've already got this one set up. Like I said in the last video where we kind of went through things really slowly, we're going to go through these a little bit quicker to see if I can get you guys some more examples to see worked out. So, we have a rational function, x squared minus 1 over x squared minus 4. First thing we do is factor it out. Top is the difference of squares, so it's x plus 1 over x minus 1. Bottom is the difference of squares, it's x plus 2, x minus 2. Now I start filling in my information. Do I have any holes? Holes occur where the function is undefined, that cancels out. In this case, nothing will cancel there, which means there's no holes. Vertical asymptotes occur where the function is undefined in lowest terms. This is undefined at 2 and negative 2, so I'll have vertical asymptotes at negative 2 and positive 2. Zeros of the function are the zeros in the numerator in lowest terms. The zeros here are 1 and negative 1. To find the y-intercept, I set x equal to 0. If I do that quickly up here, if x is 0, I get 1 times negative 1 over 2 times negative 2, which is negative 1 over negative 4, which is 1/4. So my y-intercept will be the point 0, 1/4. And then for my when I write the HO thing there, I just mean horizontal or oblique asymptote. We look at the degrees. In this case, the degree in the numerator is 2, the degree in the denominator is 2, and if we remember the rule, if the degree in the numerator is the same as the degree in the denominator, then we have a horizontal asymptote at the quotient of the leading coefficients. Bear with me 1 second. That was just my phone going off. Okay, good. We have our horizontal asymptote will occur at the quotient of the leading coefficients. And all that really means is the coefficient of this is 1, the coefficient of this is 1. So my horizontal asymptote will be at 1 over 1, which is 1. Now I have all the information I should need to graph it. So let's see if we can sketch the graph. Let's see. I have no holes, so I don't have to worry about that. I have vertical asymptotes at negative 2 and positive 2. I have zeros at 1 and negative 1. I have the y-intercept at 0, 1/4. And I'm going to have a horizontal asymptote at y equals 1. If that's 1/4, y equals 1 is above it, so we'll put it like right there. Now I have all the information I need. Now I should be able to kind of connect the dots and sketch the graph. Last time we had to add an extra point, but in this case, I can easily see I have to go from here to here and here to there. And now I should just be able to use my rules. Let's see. At this 0, we look at the degree of the 0. That's x minus 1. It's degree 1. Odd degree, the sign of the function switches around the 0, or I cut through. So I go down. If I go down, I can't come back up because I have no more zeros. So I have to shoot down to negative infinity. Over here, now we look for the behavior around the asymptote. We look at the degree of the asymptote. That's x minus 2. It's degree 1. Everything here is degree 1. That's odd degree. So just like here, sign of the function switches around the asymptote. It's negative infinity here, which means it's positive infinity here. But if I'm up there, I have to come down. I can never go down and hit 0 again because I have no more zeros, but that makes sense because I'm just going to shoot off to my asymptote right there. Now over here. Up here we have degree 1, which means I have to cut through the axis, so I go down. At this asymptote, I have degree 1, odd degree, so the sign switches around the asymptote. Negative infinity on the right, positive on the left. But if I'm up here, I have to come down. I can never hit 0 again. That works. I just shoot to my asymptote. Now I've accounted for everything. I have no holes to randomly draw. And maybe the one thing I would point out, I mean, beyond the fact that that graph just looks really cool, this has to work out. When you're doing this, just like when you're graphing polynomials, don't kind of guess and say, oh, I think this is what it should look like. It might look like this. There was only one way to connect all of these dots and all of these asymptotes, and I never had to say, well, I want it to go down here, but it's up there and it doesn't agree. Everything worked and agreed perfectly, because as long as you follow the rules, everything has to work the correct way. Good. So now, let's suppose we have another rational function. Suppose we have f of x equals x squared minus 1 all over x. Start by factoring everything. So that becomes x plus 1, x minus 1 all over x. Nothing will cancel or factor. So now we start filling in our information. 1, are there any holes? Holes occur at places that cancel out. Nothing canceled. So there's none. Then we look for vertical asymptotes. Vertical asymptotes occur where the function is undefined in lowest terms. So that's at x equals 0. Then we look for the zeros of the function. Zeros occur where it's 0 in the numerator, which is clearly at plus and minus 1. Then we look for the y-intercept. The y-intercept is what we get when x is 0, but in this case, it's going to be undefined at 0. We have a vertical asymptote there. So, there's no y-intercept. Last thing we look for is our horizontal or oblique asymptote. And in this case, we look at the degrees. The degree in the numerator is 2. The degree in the denominator equals 1. The degree in the numerator is greater than the degree in the denominator. And if you remember the rule, that means I have an oblique asymptote. Now, we actually have to find that. In order to do that, we're really quickly going to have to do something that we did a few sections ago, so you should be good with it by now. To find the oblique asymptote, you have to do the long division on your rational function. So in this case, divide x squared minus 1, I'm going to need a placeholder, 0x minus 1 by x, and see what you get. And now really quickly, because you guys can do the division, what do I multiply x by to get x squared x? I put it on top, x times x is x squared. And that's all I get. Subtract, that goes away. Bring down the 0x, but I don't actually need the 0x because it's just 0. So bring down the negative 1. I can't multiply x by anything to get negative 1. So this is just x with a remainder of negative 1. All over what I divided by x. Now, once you do the division, whatever answer you get, excluding your remainder, that is your oblique asymptote. So in this case, I get the line y equals x. This is one of the reasons we need to know how to do long division. 1, to find the zeros of the polynomial, and 2, so we can actually find our oblique asymptotes to graph these things. But now, I should be able to sketch a graph. So let's see. I have no holes, so I don't have to worry about that. I have a vertical asymptote at x equals 0, so draw that right along the axis. I have zeros at 1 and negative 1. I have no y-intercept. And I have an oblique asymptote at y equals x, which is just a 45-degree line that looks like that. Now I've accounted for everything listed over there, and I should be able to graph it. If you think about it a little bit, you can probably figure out what the graph has to look like. But if you're unsure, pick the point. If this is x equals 1, pick x equals 2 and see what the graph looks like. At x equals 2, you get 2 plus 1, that's 3, times 2 minus 1, which is 1 all over 2. You get 3 halves. So, at 2, you get 3 halves, which is slightly below that. Now, I should have enough information to graph it. Because now I know I can connect this to this. I can never go back down because I'll create a 0 that I don't have. I've already found my zeros, which means I have to go up. But that makes sense. I'll go up and approach my asymptote. At this 0, let's see. Again, all of these are odd degree, degree 1. So I'm going to cut through the axis or the sign will switch based on how you want to look at it. So in this case, make that smoother so it looks nicer. In this case, since it's odd degree, I cut through the axis, I go down. And I'll go down and approach my asymptote. Now around this asymptote, that asymptote is odd degree, so the sign of the function switches. It's negative here, so it'll be positive over here. I come down, but that's good because eventually I have to hit that 0. At that 0, that's odd degree, so I cut through the axis, I go down. I can never come back up because I have no more zeros, but that's good. I'm just going to shoot down towards that asymptote. This is not the nicest looking picture because I don't draw smooth curves very well. But again, I would stress for this one, even with this bizarre oblique asymptote and a somewhat funny looking function, there was no guessing involved in graphing it. I picked one point just to give me an idea of the direction near one of the zeros, and then the rest of it had to work the way it worked. As long as you follow the rules, these things have to work out. Okay, there is one more thing I want to do just for fun. We're not going to have time in this video, but I'll make one more video. Just another way to look at these things to maybe give you a better understanding of them.